I didn't see it.
Yeah, no, that's fine.
One moment, I'm about to send it to you.
Okay. What kind of stuff are we working on today?
Pretty much we're going over parabolas.
Okay.
Also
Parabolas as quadratics or parabolas as conic sections?
I believe quadratics.
Okay.
Those have to like graph in my calculator.
Yeah. There is a substantial difference as to the general format of a quadratic, whether you're looking at it as a parabola or a conic section. They actually use a different format. So, come on, go.
So we're pretty much describing combinations and transformations of functions from what the lesson plan says.
All right. Haven't gotten it yet. Did you send it?
Yeah, I'm about to send it.
Okay.
I just needed to find the page on the lesson plan. Okay, now I'm about to send it. Sent.
Love it. My phone always gets it before my computer does. I don't quite understand how that's possible, but all right. Is there a place you want to start?
The homework is 11 through 16.
All right. So let's look at 11. Hold it. Let me download this. I seem to be able to have more control over the image when I download it as opposed to just bringing it up. Yeah. Now I still have to do this. All right. So we have four different functions. We have f of x, we have g of x, we have h of x, and we have j of x. Express each of the functions as a composite involving one or the more of the following. So if I have y equals square root of x minus 3, well, what is that? That's y equals, what's square root of x? That's g of x minus 3. So that would be the answer for 11a. Kind of see what we're doing?
Partially.
Well, I'm looking in other words, I'm looking at this function, and it says square root of x minus 3, and I go up here and I see square root of x is g of x, so it's g of x minus 3. In other words, it's direct substitution. It's where you see you can substitute the name of the function instead of the function, you want to do it. All right?
Okay.
Let's look at B. If y equals 2 square root of x, what's another way to express that?
See that one more time?
Part 11b, if y equals 2 root x, how do I express that in terms of the functions that they've given us? What's root x?
Root of x would be, I don't know, I just remember it being just root x.
Look at these 4 functions at the top. Which one is root x?
Oh, g of x.
That's what it is. This isn't hard. This is very.
Oh, so that's all you do is substitute.
You have to do. Exactly.
Okay.
Okay, let's look at C. Well, it gets a little more complicated. X to the 1/4. Well, what would this be? In other words, you kind of have to do a little bit of if you take the square root of the, first of all, do you know what x to the 1/4 means?
Oh, yes.
It means the 4th root of x. Like that. Okay?
Okay.
Well, if I take the square root of the square root, I get the 4th root.
So g to the 4th.
Yeah, so this is actually the answer. Since g of x is the square root of x, well, what would y of the square root of the square root of x be? Well, that would be x to the 1/2 times 1/2, which is x to the 1/4, which is what we're looking at in C, is x to the 1/4. So it's the square root of g of x. Another way of stating that would be y equals g of x to the 1/2. It's important that you understand what these exponents mean. When you take the square root of something, that's the same as taking it to the 1/2 power. If you take the cube root of something, that's the same as taking it to the 1/3 power.
Okay.
Okay? All right, so let's look at D. Y equals 4x. What would that be in terms of these 4 functions up here?
I see j of x equals 2x.
Okay, so what would this be? How many j of x's?
2 j's of x's.
That's it. That's simple. In other words, 2 times 2x would be 4x. All right, let's look at y equals square root of x minus 3 cubed. This is a little more complicated. First of all, what is x minus 3 cubed?
That is x cubed plus 27.
Well, that's isn't that f of x cubed?
Yeah, that is actually.
So if we just do a direct substitution, we can do this. That's the same thing, right?
Yes.
Okay. Now it's also the square root of x. Let me think for a second here. Do you have answers for these? Do you have a book that gives you the answers for the odd ones by chance?
Say that one more time?
Do you have a book that gives you the answers for any of these?
I don't think so.
All right.
All right, wait, I can actually check. One moment.
Yeah, most books will have the answers to the odd questions.
At the end of it?
Uh-huh. Maybe not
Okay.
the even ones, but the odd ones, and this is an odd one. So I'm kind of curious as to what they say here. There's no doubt in my mind that this is correct, but I'm not sure it's fully simplified. In other words, I may be able to say that it is, oh yeah, I can say that it is G.
Okay, I found the answers.
Yeah, it's got to be G of f
Find
of
the
x,
section.
right?
I'm trying to find the section real quick.
Okay, it's 11e. But notice what I did. I found f of x cubed is correct, but then the square root of anything is g of that, because g of x is the square root of x. So this has to be the final answer. G of f of x, no, let's see, it must be g of f of x cubed, I think. I don't know, what's your
Having trouble finding it. Let me make sure I'm in the right section for
okay?
the answer.
Yeah. Let's see, f of x cubed would be x minus 3 cubed, and then g of x would be the square root of that. So I'm pretty sure this is what the answer should be. But some of these, as they get more difficult, it's nice to know that you're doing them correctly. So I'd really kind of like to know what the book says.
Okay, I think I found it. So that is number, which number is that one?
11e.
I see G, open parenthesis, H, open parenthesis, F, open parenthesis, X, then 3 close
Oh,
parenthesis.
correct, because f of x cubed can be stated as h of x. So let me see if I can figure out what they did here. They did g of f of h of x, like that?
Yes.
Is that exactly the answer?
Yep, that looks exactly like it.
Okay. And notice how they got that. In other words, if, let's start with there. This is pretty important. So let's assume they said to us, what is g of f of h of x? Well, you always start from the middle, okay? So you always start from the inside out. So h of x is x cubed. And now what is f of x cubed? Well, f is x minus 3. Hold on a moment. So it's g of, well, I'm not sure I've ever had a problem that went 3 levels deep. And this
Yeah, that's
seems to. Let's see. What is f of x cubed? F of x cubed, no, that would be x minus 3 cubed. And that's not what we want. And then g of that would be the square root of that, which would be the square root of x minus 3 cubed. Is that what we're looking at? Yes, it is.
Yep.
So the way to figure out if you have the answer correct is to go both ways. In other words, if you think that my check mark here is the correct answer, well then work your way backwards and see if you can get back to this function e. And that's really the secret on all of these. In other words, is all you're really doing is doing them in reverse. Okay? Now, if we take this one, number f, well, what is 2x minus 6? Of these four functions. If you had to define 2x minus 6 in terms of these four functions, which one would it be?
2x.
2f of x.
2f of x.
In other words, that's what that part is. And then I'm going to cube the whole thing. So let me think for a second if that's the final answer or not. Because we have an x cubed is equal to h of x. So would this be h of 2f of x cubed? Well, let's put the cubed inside. In other words, I'm not sure if that's right or not. So let's figure out what this is. That's always the best way to figure out whether you have the right answer or not, is to take what you come up with and expand it. Okay? So f of x cubed, or 2, if we put parentheses around that, 2f of x cubed is this, right?
Yes.
And we've said h of that, so h of that is that. Wow. I don't know, I got lost. Which of these do you have to do, Taylor? 11? All of them?
Not all of them. I have to do 11 to 12.
11 and 12?
Yes.
Let's go to 12. I don't want to spend my whole time figuring out 11f. Let's do 12. I haven't done these before, so I'm not maybe that great on them. So how would I express this in terms of these four functions? Well, what's 2x?
2x would be j of x.
Yeah, so let me replace that with j of x.
Minus 3.
And I think that's the answer for 12a. Do you have the answers to the even questions also, or just the odds?
Just the odd.
Okay. Do you have to do 11, 12, and 13?
No, not for this quiz.
Okay. Well, I believe that's the answer. What else could it be? Because we do have an x minus 3. So could that be,
Actually, can we do 13 as well so I can be ahead?
Let's do 13 just because I want to see what the answers are. These are tough problems. I can't say that I've done these kind of problems before. In terms of simplifying it fully, Let's look at problems that we can look up. That's always helpful. In fact, I've always felt that all math books should have the answers to odds and evens because it's helpful sometimes.
I agree.
So, all right. So let's do 13. 13, we have g of x equals x minus 13a, and f of x, these are going to be easier, equals square root of x. So what is f of g of x? In other words, when you see that symbol, the zero fog, what that means is f of g of x, like I've written. And now the best thing to do is substitute g of x. Well, that means x of minus 7. So what would that be? What is f of x minus 7? If f of x is root x, what is f of x minus 7?
Root x minus 7?
Yeah. In other words, you substitute whatever's in the parentheses for x. So that is f of g of x. And that's what that answer is, 13a. Let's look at 13b. 13b, these are easier, which leads me to believe that I just haven't done enough of those previous ones to be good at them. Because these are very straightforward here. So here they want to know fog of x, and what that means is f of g of x. What's the next thing I should write?
So f of g, so it would be...
What is g of x?
Or g of f, yeah, g of f.
What is g of x?
Would that be 3x plus 2?
No, it's just x plus 2. Right here, g of x is x plus 2. So in place of g of x, I'm going to write x plus 2. And now, what is f of x plus 2?
That would be 3x plus 2.
3 parentheses x plus 2, which is 3x plus 6.
That's it.
So that's your answer for the second one, for 13b.
Okay.
Okay. Now, they get harder. 13c, we have f of x is equal to root x minus 5, and we have f of g of x is equal to the square root of x squared minus 5. So the question is, what is g of x? In other words, we kind of have to work backwards here.
All right.
What do you think g of x would be?
G of x would be... Wait, so f g of x is square root of x squared minus 5?
Remember what the process is. We're going to take whatever g of x is, and first of all, we're going to substitute it for that. And then we're going to take f of whatever that function is, and somehow we're going to get this. So what could g of x be?
I'm guessing x because it goes from the x minus 5 to x squared minus 5.
X squared. In other words, it changes. Notice why I said x squared. Because now what would f of x squared be? Remember, you take whatever's in the parentheses and you plug it in for x. So f of x squared, this is f of x, right?
Yes.
What's f of x squared?
F of x squared is x minus 5.
Square root of, remember I'm plugging in x squared wherever I see x. So
X
x
squared,
squared there, so I'm going to plug in x squared, that's it. So that's what f of x squared is. So therefore, g of x must be x squared. And that's what they ask for in C.
Okay.
Okay. Now they get harder. G of x. Yeah, well, not really, actually. The only hard ones are where you have to figure out the first one.
I agree.
Whenever they give you g of x and f of x, really isn't that hard. You just merely have to plug it in. Well, here they're giving you g of x is that. F of x is
Same thing.
same thing. So what is g of f of x, which is what? Ooh, hold on. Let me erase that. It's fog. So it's really f of g of x. That's what fog means. The third column. So how can I state that? F of what?
G.
What is g of x?
X over x minus 1.
Yeah, see, I like that step. You always want to make that step right there. Okay, and now what is f of x over x minus 1? Remember, you take whatever's in the parentheses and you plug it in for x into the f function. Well, there's the f function.
So x over x minus 1 over x minus 1 minus 1.
Correct. That's our answer. Now, that's not very simplified, so let's simplify that. In other words, we really need, that's a very complicated quotient, and it certainly is something we can simplify. It's just complicated algebra. Well, the numerator is this. And what we have to do with the denominator is turn that into a single rational quotient. So how do you take x over x minus 1 minus 1? How do you simplify that?
Can you cross out the x over x minus 1s?
No, not yet you can't, because we've got two terms in the denominator. We have to turn that into one term. What's the common denominator? If I'm looking at this part right here, what's the common denominator?
X minus 1.
Yeah. Hold on. Just a second. So the common, whenever you have fractions that have fractions in the top and the bottom, it's always a little difficult to deal with. But here's what I'm trying to write. X minus 1 is the common denominator, and I'm subtracting. You with me?
Yes.
Okay, if x minus 1 is the common denominator, then that part is that. And what is this part right here?
That would be 1.
Remember that it's got to equal 1. Well, what do I need to write in the circled part for this whole thing to equal 1?
X minus 1.
Correct. So that's what goes there. And very important that you use parentheses here. Very important. Now, notice how that's the same thing. In other words, x minus 1 over x minus 1 is the number 1. And that's what we wanted to do. Okay? Now, let's simplify that. Well, the numerator is still this. What's the new denominator? In other words, act on the numerator of the denominator. So here's the denominator. What's the numerator?
Would the numerator be x squared?
Hold on.
Minus.
It's just x minus x, and then this minus sign has to be distributed to the 1, so it becomes x minus x plus 1. Plus 1 is what that is.
Okay.
Well, look at what I have circled on the bottom. Make sure you see why that is plus 1. In other words, I'm merely operating on the numerators here. Here's my numerator.
Once you distribute the subtraction.
Yes, and that's how I get plus 1.
Okay.
Now, how do I do this math? How do I do that algebra? How do you divide a fraction by a fraction?
Opposite, or multiply the reciprocal.
Yes. Flip and multiply. In other words, whenever you're doing division, you can always flip the bottom and multiply. Well, if I do that, I get this. And notice that good things happen. That cancels with that, and I end up with x. Now, so that's the answer, is x. Fog is x. And that's what they wanted for part D, is they wanted f of g of x. So that's all I had to do. I didn't have to work in reverse or backwards or anything. In other words, on question 13, the only tough ones, well, f might be tough, but if they give you g of x and f of x, then it's very simple. You just plug in. Okay? So there really isn't anything tough about that if they give you f of x and g of x. C was a little tough because they didn't give you g of x. They gave you the combination. You kind of had to work backwards. Let's look at E, because E does the same thing. E gives you g of x is what we're trying to solve for. Question mark. And they give you f of x is 1 minus, is that a plus or a minus there on E?
I believe that is a plus.
Let me blow it up a little bit. Yes, it is. And they give you fog.
That would be x.
Right. So now we have to figure out what g of x must be such that fog is x. So let's go back to this. What would I have to do? Wow, that's a hard one. What would I have to do to f of x to end up with just x? In other words, what could g of x be? Remember that I take g of x and I plug it in for x. So something that I plug in for x is going to result in that being x.
Yeah, that's an interesting one.
It is. Let me think about this for a second.
Since you have 1 plus 1 over x, which makes
Yeah.
it 2.
So what I really am trying to solve is this equation. Let's call it z. What does z have to be so that that is true? Well, let's solve that equation. What does z have to be? Get 1 over z equals x minus 1, which means z has to be 1 over x minus 1. That's what our answer must be. It is right there.
True.
Well, let's check. In other words, I'm saying that g of x is 1 over x minus 1. And for these, you always want to check. 1 over x minus 1. Okay? So I've come up with what I think g of x is. And now let's see if this is true, this third statement. Is f of g of x equal to x? Well, f of g of x is what? F of what?
F of g of x, that would be...
I think that's the answer, but let me prove it. So I would substitute that answer into this.
1 over 1 plus 1 over x minus 1.
No, just 1 over x minus 1. That's what I think g of x is.
Okay.
Okay. Now, let's check. In other words, what is that? What is f of 1 over x minus 1? Well, go into the f function. So you have 1 plus 1 over x minus 1, like that. That's how you do it.
Okay.
Now simplify that. Let's see if that's equal to x, because that's what we're looking for, is to make sure that this thing is equal to x. Well, if we simplify that part of it, I can flip the denominator and multiply. So I get 1 plus x minus 1. Well, that's equal to x. So we did it right. These are pretty complicated. I can't say that I've ever come across a series of problems regarding composite functions quite like these. I kind of like them. They're hard, but they're different, and they require you to think in a little bit different way. So let's take 13f. They're telling us g of x is 1 over x, and we need to find f of x. So we'll put a question mark there. And they're telling us that f of g of x, that's fog, is equal to x. So can you work backwards? In other words, what must f of x be?
To make it 1 over x. Okay.
Yeah. In other words, this is what we're trying to solve for here. What could we put in f of x such that f of g of x was equal to x? what would g of x? We know what g of x is. In other words, we can say this. G of x is 1 over x. So f of 1 over x has to be equal to x. So what does f of x have to be?
So x would have to be
Not x. What does f of x have to be? And the best way to do these is to kind of experiment. In other words, the first thing I'm going to think of is x squared.
okay.
Well, if f of x was x squared, what would f of 1 over x be?
Would that be 1 over x squared?
Yeah, and that's not right. That doesn't give us the correct answer. So let's go back and play with this. It's not x squared. Let me think for a second. G of x is definitely 1 over x, and how do you end up with x alone if gotta be one over x squared? In other words, what I meant was let's try 1 over x squared there. Okay? In other words, again, it's a little bit of a trial and error process. If we assume this is the answer for f of x, then is f of 1 over x indeed equal to x? Is that a true statement? Well, what is, if this is true, what's 1 over x? F of 1 over x?
If that's true, that would be 1 over x squared.
So it'd be 1 over x quantity squared. And that is actually equal to x squared. So we're getting closer. The answer must be 1 over x instead of 1 over x squared. This has got to be right, 1 over x. Okay? And now, if we do f of 1 over x, and f of x is 1 over x, then we get the following. We get 1 over x, and that is indeed equal to x. So this is the correct answer for f of x. And that's what they're looking for. These are hard, but they're not undoable. In other words, is all you have to do is you kind of have to try a few answers and see if it gives you all three functions correct. You know what I'm saying? In other words, if you have g of x and f of x, then figuring out fog of x is relatively straightforward. But if you have fog of x and one of the functions, working backwards is a little more difficult, but not undoable, because once you come up with an answer, like I did, I came up with 3 different answers and tried all 3 of them. And the only one that worked was the third one. If f of x is indeed 1 over x, then fog of x would be equal to x, and they're telling us that it is. So this must be f of x. There might be a better way to do these. I'm not sure. I haven't come across these. I'm not sure ever, where, you know, they give you the fog of x and they ask you to go backwards and figure out one of the two functions. So I'm not great at these, but I can figure them out and then test my solution. And that's the important part, is that once you figure out what the question mark is, then you have to test. In other words, I came up with an f of x that was 1 over x. Okay, well now I have g of x and I have f of x, so is fog of x equal to x? And it turns out that it is, as long as f of x is 1 over x. So you kind of have to do them like that, I think. What's the next problem you have? Size 11, 12, and 13.
I could go to 15. Yeah, 15 works.
Okay. So evaluate each expression using the given table of values. So if x is minus 2 and f of x was 1, so what is f of x? So f of x is a question mark, and x is equal to minus 2. So f of x, f of minus 2 has to be equal to 1. Well, what
And
about if I have an f of x of minus 2 over x? There's my function f of x.
Okay.
What would f of minus 2 be?
So f of minus 2, that would be negative 2 over negative 2, and that would be
That would
1.
be 1. So that's how I got it. I wanted to make sure that f of minus 2 was 1. Okay. Now let's see if we can come up with a formula as to how we actually did that. Let's see. We don't have that much time. If we do the second one, I get f of minus 1 needs to be equal to 0. Well, the only way something is equal to 0 is if the numerator is equal to 0. So, wow, these are tricky. These are good. You go to a good school. They ask questions that are outside the Common Core.
Yep.
And they're very, very tricky. How did I figure out the first one? I figured out that you had to have minus 2 over minus 2 to get 1. How can you get 0? Oh, the x must be... No, the x can't be in the numerator. Numerator must be 0 over x. And then f of minus 1 would be equal to 0. That answer doesn't make much sense to me. Not sure I fully understand exactly. I don't see the bottom of this problem. It's cut off, and I'm not sure if there's something missing there. Then I'm not,
Actually, there isn't anything missing.
there's nothing missing?
You know there isn't. Except the only thing that is there missing from the table,
Uh-huh.
everything in the table is there. However, it says A, F open parenthesis, G open parenthesis, -1, 2 closing parentheses.
Okay.
We can do it another time because we're out of
Yeah,
time tonight.
we're gonna have to, I guess. Um,
Okay.
yeah. Well, I'll let you go for now. These were tough. These were very interesting problems. But definitely a cut above. Tough problem.
Okay.
All right, Taylor, I'll talk to you next time.
Thank you. Sounds good. Have a good night. Bye.
Bye-bye.